Okay, this is solving systems of linear equations, and we just have two of them. We don't have three like the old days. But now it's a couple of different ways we're going to show you over the next 2 days. Whoops, what happened there? Okay, last day was graphing. And today we're going to do what's called the substitution method primarily. For our new book, we also have inspection as well. So I'll quickly go over inspection. Okay, we saw that word when we did factoring. It was one method to do factoring if it was a simplified equation. In other words, throw down two sets of brackets and trial and error. See if you can come up with the answer. That's essentially what we're doing here. Looking at this guy, it's saying it's a pretty simple one as far as equations go. Maybe you can just see the answer. Okay, trial and error. Can you do it by inspection? Can you see what values of x and y will work? And some of you will be pretty quick at this, and others, you may not get the answer. Okay, so in other words, well, I look here and I say if y was 6, I'd have 12, so then x would be 0. Let's see if it works here too. Right? If y is 6, I got 18, and x would have to be -1 for this to work, so that doesn't work. They're not the same. Let's try something else. What? 3 maybe? Okay. Well, if y is 3, that would be 6, and then x would have to be 6 for this to work. Let's see if it works here. Whoop. Y is 3, not 2. 9 and 6, that's 15, not 17. So this is what we're getting at, okay? Some of you might have looked and went, well, trial and error. If you guess and you're lucky, maybe you found out that if y is 5, I'd get 10, so x would have to be 2. And if y is 5 here, I got 15, and x would have to be 2. Bingo, that's it. Okay? Now, I'm probably not going to give you something, well, I don't know, that could be incorrect. On the quiz or the test, you might get something that simple. But the question will be, show your work. So if you do it by inspection, I don't know if I can give you full credit for that. Here's what we're actually going to try to teach you to do. This is a method called substitution. Okay? Here's the steps. In the past, remember I told you you can solve this thing because you have one equation, only one variable. As soon as you introduce another variable in here, well, how do we solve this? Is there only one answer that will work for x and y, or are there multiple values? We kind of, to get the exact answer, because I have two variables, I need two equations, as that would probably explain when we did graphing, okay? So I don't have a graph here. I could have graphed that just like we did before, but there's another way. Substitution. What do these say? Choose the simpler equation and express it in terms of one of the variables. So if, for example, x is something, I'm going to take that value of x, substitute it in the other equation, and then solve it. Because if x is some value in terms of y, and I put it in the other equation for x, I'm going to have one equation with one variable. Okay? And I can solve that. That's exactly what this is telling us to do. Okay, so once you solve the one equation for the variable, you substitute it in the other equation, or either one of them, it doesn't really matter. Get the other variable, and then of course, just like we did in graphing, we're going to have our solution as a coordinate point in terms of x and y. So here's a system of equations. Okay, solve it. It's saying rewrite the first one in terms of x. What's this guy in terms of x? All I got to do is get that 4y, throw it to the other side of the equation. It becomes negative, and that's what the first equation is in terms of x. Okay? That's step 1. Step 2, substitute this into the other equation. I made a mistake. That's supposed to be a y. Okay, this is what x is. 17 minus 4y. I'm going to take that and put it in the other equation for x. So I've got 2 times x. What's x? It's 17 minus 4y minus y equals 7. And I've got one equation, one variable. I can solve this thing for y. 2 times 17 is 34. This is called distributive property again, remember? 2 times that is minus 8y. Minus y is 7. Okay? Minus 8y minus y, that's minus 9y. Equals, and I'm going to cheat a bit, do 2 steps at once. Take this 34, put it to the other side of the equation, collect it with the 7, so that will become minus 34. Okay? Again, I'm just subtracting 34 to both sides, right? Getting rid of this one. So 7 minus 34 is minus 27. Last step. Divide by 9. Y is by itself. I've solved it for y. A negative divided by a negative is a positive. 27 over 9 is 3. Nice whole number. Okay? I can't guarantee you'll always get nice whole numbers, but at least for the start, it's nice when they are. It's easier to work with. Now that's not the that's not the answer. That's not the solution. I didn't solve the system. All I did was find out what y is. So now I need to take this last step says, substitute that into an equation and find the value of the other variable. So it doesn't matter which one I use. Okay? Because I'm trying to find the solution. I'm trying to find where these 2 lines cross. And it's going to be the same coordinate point, which is the same for both of the lines. So I can substitute that in here, solve it for x, or I can substitute it in that one and solve it for x. Doesn't matter which one. So let's put it in the second one. 2x minus y, y is 3, equals 7. I'm going to solve this thing for x. So 2x minus 3 is 7. Add 3 to both sides. 2x is 10. Divide by 2. And x is 5. So as a solution, that is the coordinate point. Okay? And like I said, I could have used that one. I would have got the same thing. Okay? Now, I believe it will say verify the solution. And yes, I'm going to do it the second way, but first let's check this, okay? So, this is a coordinate point. It better work in both of these. So if x is 5, I've got 5 plus 4 times 3. Is that equal to 17? 12 and 5, check. It works. In the second equation, 2 times x minus y, is that equal to 7? 10 take away 3 is 7? Yes. Okay? So I've checked it. I know that's the solution. That's the only point that satisfies both of these 2 equations. So, is there another way to do this? Of course there is. This one says, rewrite the first equation in the form y equals. I'm actually going to do the second one, okay? Because I don't want to write that one in terms of y. I'm going to have to divide by 4. That's going to be ugly. This one has y. All I need to do to get y by itself is put it over there. And take that 7 and put it over there. Okay? So y is 2x minus 7. Yes, there's lots of ways to solve this thing for y. That's how my brain works. Okay? Double check it first. Make sure it's correct, because if that's wrong, everything else is going to be wrong. But I've solved the second equation for y. I'm going to take this and substitute it in the first equation for y. X plus 4 times y but y is 2x minus 7, okay? So again, x plus 4y equals 17. I'm going to solve that thing for x. That's the only variable in here. X plus 8x, distributive property, minus 28 is 17. Collect your x's. Collect your numbers. Okay, put 28 over the other side, change the sign. So now it's positive 28. And that is 45. Divide by 9, divide by 9, and once again, I get x is 5. Okay, if I substitute that back into either one of these equations and find out what y is, you will find you get the same thing, but I may as well do it. Let's use the first one this time. X plus 4y is 17. Okay, if x is 5, let's see what y is. Minus 5 minus 5. Divide by 4, I think you can see that y is, in fact, 3 again. Okay? So, either way, now they're implying that if I had to use the first equation, obviously that would have been a lot more difficult. Because to solve this thing for y, I would have had to divide the 4 away. Okay? And I chose not to do that. So to answer this question, they're both about the same amount of work. Okay? And, well, I've already verified this point. I know it works in both equations, so that is the solution. So this is substitution. No graph required. Okay? So yes, it's a little more algebra. It's less visual. But I don't know if in senior grades anybody would pull out a piece of graph paper if they had one handy to try to get the solution. Okay? They would do this way. Or maybe with elimination method, which we will show you tomorrow. Okay, so that's it for substitution. This one looks, well, it ends up being a really nasty answer. It actually is fractions, and therefore I don't even know if you can graph that one to find a solution, because when you got answers like negative 1/3 and 1/4, it makes it pretty tough visually to find it out. So I'm just going to skip that one for now. And even to start, I mean, how do you even solve this thing for x? You're going to have to divide by 4, you get a nasty fraction. Solving this for y, you got to get rid of that 3, you're going to have a nasty fraction. Same here, right? There isn't one of these that's all by itself. Okay, I don't know, something like that. I would choose to solve that one for x. Okay, because the first step says choose the simpler equation. There isn't anything simple about either one of those. Okay, it's a nasty one, so if you're looking for a reason why I'm skipping it, that's it. Okay, so assign